If this car moved from point A to point B, we could say it traveled a total distance of 100 meters. Let's bring this one in so we have a direction. Now, if the car again traveled from point A to point B, we could say that it traveled a distance of 100 meters, but we can add in another part of this measurement. We could say it traveled 100 meters to the east. And this is actually a displacement rather than a distance. The difference is that we're including a direction this time around. Now, the definition for displacement is the overall change in position. So we're looking at a starting position comparing it to a finishing position. And then the other big difference here is that displacement is going to include a direction. Now, displacement includes a direction, and so we call this measurement a vector. And so measurements that include directions are called vectors. Distance doesn't include a direction, and so it's called a scalar. Let's add another road sign here in our example. So if we add this extra midpoint here, road sign, it'll bring our car back to the point A. And if the car travels from point A to point B, and then just backs up here to the center here, let's see how far it traveled. Now it's traveled a distance there from point A to point B of 100 meters, and then it traveled an additional 50 meters for a total distance of 150 meters. Now, if we look at its displacement, however, we're comparing its starting position, which was right here, to its finishing position, which is right here. And so its total displacement would be 50 meters to the east. In other words, it's 50 meters east of where it started, which was right here. Let's look at another example here. If you've ever run track and field, you may have had the chance to run the 400-meter race. The 400-meter race is one lap around the track and for a total distance of 400 meters. Now, what would the displacement be? Well, if we compare your starting position right here to your ending position right here, we would say that your total displacement was 0 meters. And it's almost like if you were running the race and all the fans just shut their eyes as soon as the gun went off and then opened them again when it was all over, and it looks like you're in the exact same location. Your displacement is 0.
In this video, we're going to discuss the difference between distance and displacement. Let's go to the left. We're following a path. It's leading us to some destination. We're traveling a distance. We can measure this with different tools. Avoid the trees. Oh, a little curve there. And eventually, hopefully, find our path again. Yeah, there it is. We'll reach a destination. We've traveled a distance from our origin to the destination. We can measure that distance marked in red. Now, we'd like to go on a straight line path, of course. There's a mountain in the way. We've got to do something about all right, this works. Now we're going to be able to travel a displacement. A displacement starts at the same origin, but it travels in a straight line from our origin to our destination. This is usually much, much shorter, and there is our destination. We've traveled a displacement, marked in green, versus a distance, marked in red.
Learning the terms. Every object on Earth is either at rest or is in motion. When an object moves, it goes from its initial position to another position. This man walks from the house to the bank, traveling 100 meters. From there, he walks back 30 meters and stops at the lamp post. So the man has walked 130 meters. The length that the body has traveled is said to be the distance covered. Therefore, here, distance equals 130 meters. But how far is he from his house? The starting point of the man's movement is the house, and the end point is the lamp post. The distance between these 2 points is 70 meters. He is just 70 meters from his house. So the displacement is 70 meters. Displacement is defined as the shortest distance between the initial point and the final point of a journey. Displacement can also be defined as the distance covered in a particular direction. Displacement is always less than or equal to distance. Here are some visuals to show you the distance and displacement for different situations. The distance covered is indicated by a red line, while the yellow line indicates the displacement. The child comes down the slide and walks to the center of the base. The top of the slide is at a height of 4 meters from the base. The other measurements are displayed. The distance covered is 5 meters plus 3 meters, that is 8 meters. Displacement is the shortest distance between the start and end point. Here, displacement is 4 meters. This circular track has a radius of 21 meters. The athlete travels half the circumference. Thus, the distance covered is given by pi r, that is 21 into 22 divided by 7, which is equal to 66 meters. And the displacement is equal to the diameter, as the diameter is the shortest distance between the initial and the final positions of the athlete. Therefore, the displacement is 2r, which is equal to 42 meters. The ball is thrown in the air and caught. It travels up for 3 meters and returns to the same place. Distance covered is equal to 6 meters. The starting point of the journey of the ball and end point are the same. Therefore, displacement is equal to 0.